Hello everyone, I am creating this video to teach you how to find the inverse of any matrix. As you can see here, the question asks you to find the inverse of matrix A, and matrix A is a 3 cross 3 matrix. 1 3 0 minus 2 3 3 1 1 4 are the various elements. Now the first thing you need to remember is that the formula of A inverse is adjoint A divided by the determinant of A. As a first step, let me find the denominator, which is the determinant of A. Now remember, when finding the determinant, you need to apply these symbols if you are finding the determinants with the help of the first row of the matrix. So, the process is like this: 1 into the minor of the element. So, to find the minor of the element 1, you need to eliminate the row and column to which this element 1 belongs to, and the minor will be 3 into 4 minus 1 into 3. As you can see, that's how we got 1 into 3 into 4 is 12 minus 1 into 3, and that's how I got this number. Now similarly, next I will take into consideration this sign, which is minus 3 into the minor of this element. Once again, to find the minor, eliminate the row and column to which that element belongs to. So inside the brackets will be minus 2 into 4 minus 1 into 3. Minus 2 into 4, I get minus 8 and minus 3. Finally, plus, taking into consideration this sign, 0 into the minor of this element. Once again, the minor will be minus 2 times 1 minus 1 into 3, which is how I got minus 2 minus 3 over here. In this particular example, this element is 0, so this entire thing will come up to 0, but it will differ from matrix to matrix. When you solve this equation, you will get a value 42. Remember, if the value of the determinant comes out to be 0, it's a singular matrix and you will not be able to find its inverse. So, you can find the inverse only for non-singular square matrices. The next step will be to find the adjoint of the matrix A. This is the original matrix. This is the original matrix, and to find the adjoint, I am going to find the minor matrix of A for which I am denoting the minor for the first element A11. I am denoting it as M11. Now, the minor, as we did for the determinant, is found by eliminating the row and column to which 1 belongs to. So, M11 will be 3 into 1 minus 1 into 3. Sorry. It is actually 4. The last element is actually 4. So, M11 will be 3 into 4, which is 12, minus 1 into 3. So, M11, the value is 9. Similarly, M12 will be the minor corresponding to this element. So, the value of that minor, like we did for the determinant, will be minus 2 into 4 minus 1 into 3. So I get that as minus 11. Similarly, M13 would denote the minor of this element. To find the minor, eliminate the row and column to which the element belongs to, and Cross multiplication of the remaining elements will be minus 2 into 1 minus 1 into 3. So that is minus 5. Similarly, you can find the values of all other minors. M21, M22, M23, and the final row M31, M32 and M33. And that is how I get the minor matrix of A. The next step from minor matrix is to find the cofactor matrix. The cofactor matrix is nothing but the minor matrix with the appropriate signs. And what are the appropriate signs? Starts with plus and alternates plus minus, plus minus, plus minus, and plus minus plus. Right? So applying these signs to the elements in the minor matrix, I will get plus 9, minus of minus 11 is positive 11, plus minus 5 is minus 5, minus of positive 12 is negative 12, plus 1 is 1, minus of minus 2 becomes positive 2, positive 9, minus of positive 3 becomes minus 3, and plus 9 becomes positive 9. Once you have found the cofactor matrix, the next step is to take its transpose. And the transpose of the cofactor matrix is called the adjoint of the matrix A. To take the transpose, you are simply interchanging the rows and columns of the matrix. So, the first row of this matrix is 9, 11, minus 5. I am going to make it the first column. The second row is minus 12, 1 and 2. I am going to make that the second column to find the transpose. So, minus 12, 1, 2. Similarly, the third row is 9, minus 3 and 9, and I am going to make that the third column. So, you have found the numerator which is adjoint of matrix A, and you know that the determinant of A or the denominator has the value 42. The value of the inverse, like I said, is adjoint A divided by determinant A. So, it will be 1 by 42 times 9 minus 12, 9, 11, 1, minus 3, minus 5, 2, 9. And if you have your calculators, you can always find the decimal points, or you can even leave it here and this would be your answer.